This not we are going gradually towards what to mean by what? Differential calculus. When you're talking about first principle, the first principle has to do with how you get the value of the rate of change. So, because calculus has to do with the rate of change, that is the rate of change of a value with respect to the other. Like if you have y as a function of x, so you want to look at a little change, what a change in x, the impact of the change in x on y. So like this, you can have it in several parts. So what they are telling you is not abstract. It's something that you are conversant with in day-to-day activity. Talking about the rate of change. So in physics, you can talk about the rate of change. So look at distance and then you have time. Now, when you have is change of displacement. So over time is what you refer to as velocity. So the rest, the t, that's your definition of velocity. So when a car change velocity, so it's either it moves slower or faster. So it's something that is practical. So you can equally measure your acceleration. Maybe when you change your velocity, you speed more or less. So that's it. Then when you accelerate more, your motor move forward more. So that's it. So you have the rate of velocity over time. So that's the VDT. This one is velocity, while this is acceleration. So you have this one as this. So this is what they are simply expressing like this. So you have them like that in different things. What about even in chemical production? You may want to look at the effect of little change. That is, if you have little chemical to something, to a compound, what effect is it going to have on the general or on the usage? So that's it. You have them like that. So in economics, you know about demand and supply and the price. Then you want to look at it that you have price, you have quantity. Then you may want to look at the impact, the rate of change, the Q, the P. That is the rate of change of price over P or on P, be on P. If there is increase in price, what effect is it going to have on what? On quantity. So you have them like that on and on. So that is it. In economics, you do differential calculus because it's relevant in the field of economics. So to measure the rate of change, what if impact is okay? If you want to look at economic growth, then you're talking about the impact of exchange rate on economic growth. If there is what increase in exchange rate, if there is depression, a depression in exchange rate, what effect? A little change. Is that increase or decrease? What impact is it going to have on economic growth? So and the like. So you have them like that in different aspects. So now that's why in the basic form, uh, you have this sign called delta. Delta. Delta is what we refer to as the rate of that's change. So if you have two variables, y is a function of x. So you want to look at the rate of change of y with respect to x. So what you have here is y, that is a little change in y. That is a little change in x. You want to look at the effect on y. If this one change more, this one change more. Okay, what will be the effect? So what you have here is change in y equal to x plus change in this minus this. So this is it. You have this one. This one you minus it from this. So remember that y equal to x. So you substitute for this. So here you have delta y equal to x plus change in x minus x. So this is what we have here. Then you divide through by what? Here, this minus this, you have this equal to this. Then the x divided by dx. So this is what we have. The rate of change, that's delta x. This cancel this 1. That's it. I will tell you how that one is later. Now, that's a simple way you can do. That's for just a simple x and y, relation between x and y. So you can look at this. Look at this one. See, using first principle. Here we are talking about first principle. First principle. The first principle, they are saying using first principle, differentiate. Say find the derivative of. So using first principle, find the derivative of, let's say you have x squared plus 3x. Now look, here is find the derivative of this. The first thing you do is y equal to x squared plus 3x. So because it's functions of this. So as we have this one now. Now each of this one, if you have y plus change in y, is going to give you x plus change in x squared plus 3 into bracket change in x. So this is it. What you simply do, this one change small. This is it. A little change in y. A little change in x is s that's changing. This is constant. So you have this one as constant change in this x. So you have it like this. So the next thing you are going to do is to expand this. If you expand this, you will have x. You will have x squared. That we just say you have x squared, or have it like this first. Plus 3 into bracket x plus change in x. So if you multiply it out, this multiply by this, you will have x squared. This multiply by this, you will have x change in x, x change in x plus x squared. This times this, this times this, and this multiply by, you have that. Then for this, you have 3x plus 3 change in x. So this is what you have. Open bracket for this. So remember, you have this like this, y plus change in y. Now, what you have here again is you subtract this one from both sides. So here you will have change in y equal to x squared plus x change in x. This one will be 2 change in x. This plus this. That's 2x change in x plus x squared. That's change in x squared. Plus 3x plus 3 change in x. Then minus y. Then you remember that y, that is, here you have y here, 3 as what? X squared plus 3x. So you substitute this for this. So you have y equal to x squared, 2x change in x plus this, plus 3x plus 3 change in x minus into brackets. This one, x squared plus 3x. So that's it. After expanding this, you minus y from, and this is value of y equal to this. You put it here. If you open bracket for this, here you have this equal to x squared plus 2x change in x plus change in x squared plus 3x plus 3 change in x minus x squared minus 3x. So look at this. This minus this. That's gone. Again, look at this. This minus this. That has gone. So what you have left is this 2x change in x plus this squared plus 1 3 change in x. Now, when you are doing first principle, we are introducing limits again. The limit you are introducing is as we divide this everything by 1 x x will tend to 0. So we divide through by what? Divide through by delta x as delta x tends to 0. That's it. So you have this divided by delta x as delta x tends to 0. So you have it like this 2x plus 2x change in x plus change in x squared plus 3 change in x. So everything divided by change in x. So this you can use them to divide each of them. So what you have here is 2x change in x divided by change in x plus this change in x plus 3 change in x over change in x. So what you have here is here you have the y delta to delta x as delta x tend to what? Tend to 0. This will cancel this. This will cancel it. So 1 will cancel out here. Then you will have 2x plus delta x plus 3. Then we see as delta x tend to 0. So this one will be 0. Then you will have 2x plus 0 plus 3. Then your answer will be what? Delta x y to delta x equal to 2x plus 3. So that is it.